Good morning. My name is Bill Owen, and along with Csaba Henk, we're going to be introducing you to the
Good morning.
To the Manila OpenStack project. And in particular, how we're using the Ganesha NFS server to simply and quickly create Manila drivers. And those Manila drivers can connect to a variety of back-end storage technologies. By now, most OpenStackers have heard of the Manila project. But to reiterate, Manila is a service for providing shared file system resources to a collection of OpenStack VMs. Manila is currently in incubation status and supports NFS and SMB protocols, with more protocols planned in the future. Manila manages shared file system resources in a heterogeneous storage environment where Manila drivers provide a common interface to various storage backends. For example, with Manila, you can create or delete file system shares, and then use Manila to provide access or remove access to one or more VMs. What makes Manila unique, though, is that you can also create shared file system resources and share those with bare metal machines also. So with Manila, you can manage an environment that includes both virtual and physical machines. So Ganesha is an open source project that's been evolving over the past years. There are two features in particular that make Ganesha interesting and attractive for our use. First, it's a user mode implementation. And in user mode, that provides a variety of benefits, in particular in terms of flexibility and extensibility. Second, Ganesha uses a modular architecture. And in particular, it has a file system abstraction layer, or FSAL. And what FSAL does is encapsulates the details of various file system technologies and provides a common management interface for those. This means with that common management interface, you can write a common driver that will be able to control or manage a variety of storage technology backends. Okay, so let's look at the Ganesha-based Manila drivers today. So first of all, I want to point out that the diagrams abstract most of the details of an actual connection. What we're trying to show is just that the file system shares created on various back-end technologies can be managed and made available to our tenant nodes. The Manila drivers are out of the data path. So they're just there for orchestrating the creation of resources and managing access to those resources. So we're showing them on the side here. We show the NFS Ganesha server and the Gluster and GPFS FSALs, as well as the Gluster and GPFS Manila drivers. So the key point is that with Ganesha, we're able to easily and quickly create create drivers, Manila drivers, for both GPFS and Gluster. Both drivers have been submitted to the community and are being reviewed now. The current limitation is that both of these drivers work in a flat network, so there's no network separation. And I'm going to hand it over to Csaba now, who's going to go through our plans on how to improve on that.
Thank you very much, Bill. So what I want to start with is the Manila generic driver, which is quite a reference implementation for a properly network separated share infrastructure. What it does, it keeps the different tenants in separate networks, and it applies so-called service VMs, virtual machines, which provide access to the shares, to the storage backends for the VMs. And how it's done in the generic driver is that these service VMs are installed with the kernel NFS server, so they are available for the tenants as NFS export that way. And on the other direction, the service VMs have connections to the storage backend. And in the current generic driver implementation, that storage backend is basically a Cinder volume formatted and mounted by the service VM. So the generic driver is a full open source storage stack, but it's a limitation of it that it can only do Cinder. So there are a lot of storage, distributed storage technologies, and the main point would be to leverage all those and allow to integrate with Manila, and the generic driver is only Cinder, so that's what we are to change. So this is the combined diagram that we want to achieve. So use this same kind of networking architecture that is introduced with the generic driver, have the separate networks for the tenants, and have service VMs that allow the tenants to connect to the storage backends. But instead of the kernel NFS server, we want to run the NFS Ganesha server on the service VMs. So basically, here was this kind of diagram. We take that green box of it and sort of uploaded it to the service VM. And that way, we can connect to any storage backend that is supported by Ganesha. So what we gain by this effort is that it's a kind of best of both worlds. We both get the flexible backends of Ganesha and the network separation of the generic driver. And also, you can use it as a full open source stack, but you can also plug in vendor-specific proprietary technologies. And so at the Ganesha layer, actually for the driver, for the developers who creates driver, manifests as a reusable component that implements share provision and access control, and it's very easy to plug in to your driver to implement, to get those features just with a few lines of code. And we want to reach that point in the kilo time frame. So that's what we want to tell you about. Here you find the links for the Manila project. So thank you very much. Do you have any questions?